OTEC stands for Ocean Thermal Energy Conversion, which basically takes hot surface water and exchanges heat with deep sea, cold seawater, and that if you have any temperature difference, you can run an organic Rankine cycle, which is basically a power generation cycle. The main problem with OTEC is that it has an inherently low thermodynamic efficiency. I've actually been interested in energy research for a long time now. I started as an undergraduate, where I started working at the heat pump lab to get a feel for how energy research is done. And then I switched labs to focus more on heat transfer, which is actually my particular interest. I believe the reason why I'm interested in energy research is because I believe we have a responsibility to protect the Earth's environment and its resources, and renewable energy is very important for that. So we are at a very exciting time for renewable energy, where there's still a lot of room for innovation and creativity. In our lab, we have some very good ideas of how to improve the OTEC cycle to make it more thermodynamically and economically feasible. The fellowship will give me the opportunity to fully develop the technology in order to make it in order to improve it as much as possible. The main difficulty with the OTEC system is the low thermodynamic efficiency. That causes two problems. First problem is that it becomes a struggle to produce net power, because the power required to operate the cycle is very comparable to the power you produce. That problem can be alleviated if we have better heat exchangers that can reduce the amount of power it takes to operate the cycle in order to make it economically feasible. The second problem that also produces is because the efficiency is so low, you need to transfer a lot of heat. In order to do that, you need very, very extensive heat exchangers, which is expensive, and that will increase the cost of the electricity. And so the way we're trying to fix this is by creating a new type of heat exchanger that will require very little power to actually operate. And also we want to make it more efficient, so it requires less volume. We have a lot of modeling results that indicate that if we redesign the heat exchanger, we can make it a lot more efficient. So we are hoping to verify these models by designing a new heat exchanger and then testing them against the model. I just want to thank the Hulka family for giving me the opportunity to contribute to the field of renewable energy research. It is an extreme honor to be able to contribute to this field and use my creativity to help develop it as much as I can. I hope that I can live up to your expectations and the high expectations of this university. Thank you.